Imagine looking into the night sky and discovering a star moving so fast that it is escaping our entire galaxy. It sounds impossible, yet that's exactly what astronomers found, and Hubble helped reveal how this incredible journey began. Our solar system is constantly moving. The Sun travels around the center of the Milky Way at nearly 220 kilometers per second, completing one orbit every 230 million years. Every star in our galaxy is moving. Some travel slightly faster, others move a little slower, but they all remain bound by one invisible force: gravity. For billions of years, gravity has held the Milky Way together, keeping hundreds of billions of stars locked in their orbits around the galaxy's center. Astronomers believed this was simply how galaxies worked. Then they found something that didn't fit. A star moving so incredibly fast that it wasn't orbiting the Milky Way at all. It was escaping, not drifting, not wandering, leaving. Its speed was so extraordinary that the galaxy's gravity could no longer hold on to it. For the first time, scientists realized that stars were capable of doing something once thought impossible. They could break free from an entire galaxy. Finding a fast-moving star is one thing. Proving that it is escaping an entire galaxy is another. That requires years of careful observation. This is where the Hubble Space Telescope became essential. Orbiting above Earth's atmosphere, Hubble can measure the positions of distant stars with extraordinary precision. By comparing images taken years apart, astronomers can detect tiny changes in a star's position across the sky. Combined with measurements of its speed toward or away from Earth, scientists can reconstruct the star's true motion through space. One particular star stood out. It was traveling at well over 1.5 million kilometers per hour, fast enough to exceed the Milky Way's escape velocity. Its trajectory pointed away from the center of our galaxy. Every new observation confirmed the same conclusion. This star was not returning. It was beginning an endless journey into intergalactic space. Hubble didn't simply capture a beautiful image. It helped reveal one of the fastest stellar journeys ever measured. Escaping a planet is difficult. Escaping a star is even harder. Escaping an entire galaxy is almost unimaginable. To leave the Milky Way forever, a star must reach an extraordinary speed. If it travels too slowly, gravity eventually pulls it back. But once it exceeds the galaxy's escape velocity, there is no return. From that moment forward, the star becomes a traveler between galaxies. Its destination is uncertain. It may drift through the vast emptiness of intergalactic space for billions of years. It may never orbit another galaxy again. Or perhaps, far in the distant future, it could be captured by another giant galaxy through gravity alone. For now, it is simply moving into the unknown. A journey unlike almost anything else in the universe. The question was no longer whether the star was escaping. The real mystery had become: what could possibly launch an entire star to such an incredible speed? Astronomers had confirmed something extraordinary. A star was escaping the Milky Way. But stars cannot accelerate themselves to such incredible speeds. Something, or someone, had launched it. To solve that mystery, scientists turned their attention to the violent heart of our galaxy. And what they found changed everything. At the very center of the Milky Way lies an object unlike anything in our solar system. Hidden behind vast clouds of gas and dust is Sagittarius A*, the supermassive black hole that anchors our galaxy. Although invisible, its gravity controls the motion of millions of nearby stars. For decades, astronomers tracked these stars as they raced around an apparently empty point in space. Some completed their orbits in just a few years. Their incredible speeds revealed the presence of something with a mass equal to about 4 million suns, compressed into an astonishingly small region. Sagittarius A asterisk is not constantly pulling stars into itself. Most stars orbit it safely, just as the planets orbit the sun. But occasionally, a star ventures far too close. When that happens, gravity can transform a peaceful orbit into one of the most violent events in the galaxy. The escaping stars observed by Hubble are not random accidents. Many are believed to begin their journey here, at the heart of the Milky Way. How do you launch an entire star out of a galaxy? The answer may begin with two stars, not one. Many stars are born as binary systems, where two stars orbit each other for millions, or even billions, of years. Imagine such a pair drifting too close to Sagittarius A star. As the binary approaches the black hole, the difference in gravitational force across the system becomes enormous. The delicate balance holding the two stars together breaks apart. One star is pulled into a tight orbit around the black hole. The other is flung away at extraordinary speed. This process is known as the Hills mechanism, named after astronomer Jack Hills, who first proposed the idea in 1988. It acts like a cosmic slingshot. The black hole doesn't simply throw a star. Instead, gravity transfers orbital energy from the binary system. One star loses energy and remains trapped. The other gains enough energy to escape the Milky Way entirely. What sounds like science fiction is now considered the leading explanation for many hypervelocity stars. The theory was compelling, but science demands evidence. Astronomers needed to prove that these stars were truly leaving the galaxy. This required combining observations from multiple missions. The Hubble Space Telescope measured tiny changes in stellar positions over time. The Gaia spacecraft mapped the motions of more than 1 billion stars with unprecedented precision. Ground-based observatories measured how fast these stars were moving toward or away from Earth using spectroscopy. Together, these observations revealed both the stars' speed and direction. Some were traveling fast enough to exceed the Milky Way's escape velocity. Others traced paths leading directly back toward the galactic center. The evidence fit remarkably well with the Hills mechanism. Hypervelocity stars were no longer just a theoretical prediction. They had become observable proof of the extreme gravitational power hidden at the heart of our galaxy. Every escaping star tells the same story. Somewhere in the distant past, it survived a close encounter with one of the most powerful objects in the universe. The mystery of the star's incredible speed had finally been explained, not by an explosion, not by an unseen force, but by gravity itself. Yet one question remained. Once a star escapes the Milky Way, where does its journey actually end? Escaping the Milky Way is not like leaving a planet. There is no atmosphere to cross, no visible boundary. The edge of our galaxy gradually fades into a vast halo of stars, dark matter, and extremely thin clouds of gas. Once a hypervelocity star exceeds the Milky Way's escape velocity, gravity can no longer pull it back into a stable orbit. Its journey becomes one way. As millions of years pass, the galaxy behind it slowly shrinks into the distance. The familiar spiral arms fade. The bright glow of the galactic center becomes just another point of light. Eventually, the star enters one of the loneliest places in the universe, intergalactic space. Here, the distance between galaxies is measured not in light years, but in millions of light years. For billions of years, the star may travel through almost complete darkness, carrying nothing but the momentum it gained during its dramatic encounter with Sagittarius A star. Can an escaping star ever reach another galaxy? In theory, yes. In reality, the answer is far more complicated. The nearest large galaxy to the Milky Way is Andromeda, located about 2.5 million light-years away. Even for a hypervelocity star moving at extraordinary speed, the journey would take millions of years. Long before that could happen, something even more remarkable will occur. Astronomers know that the Milky Way and Andromeda are slowly moving toward one another. In about 4.5 billion years, the two galaxies are expected to begin merging. By then, many hypervelocity stars will still be traveling through intergalactic space. Some may continue drifting forever. Others could eventually be captured by the gravity of the newly forming giant galaxy created by the merger. Their destination is uncertain, but their journey reminds us that galaxies are not isolated islands. They are part of an ever-changing cosmic landscape. Hypervelocity stars are more than astronomical curiosities. They are natural probes of our galaxy. By tracing their paths backward, astronomers can study the invisible gravitational forces shaping the Milky Way. These stars also help scientists investigate the distribution of dark matter surrounding our galaxy. Their motion provides clues about regions that cannot be observed directly. Future missions will reveal even more. The Gaia spacecraft continues to measure stellar positions with extraordinary precision. The Nancy Grace Roman Space Telescope will expand our ability to observe distant stars and their motions across the galaxy. Each new discovery improves our understanding of how galaxies evolve, how black holes influence their surroundings, and how gravity shapes the universe on the largest scales. A single escaping star can tell the story of an entire galaxy. For thousands of years, humanity believed the stars were permanent fixtures of the night sky. Today we know something far more extraordinary. Some stars are travelers. Launched by the immense gravity of the Milky Way's central black hole, they leave their home galaxy forever. Hubble helped reveal one of these incredible journeys, not because it watched a star race across the sky in real time, but because it measured the tiny movements that, over years of observation, uncovered an extraordinary truth. Even entire stars can be set free, and somewhere in the darkness between galaxies, one of them is still traveling. A silent reminder that in the universe, even the impossible can become reality.